So to repel the power supply, which might be worth fixing, but let's try to fix it anyway. Here's the simplified fridge schematic of it. In one of my previous videos, I did this way of sweeping up following all the components in red says to be not bad. It was also difficult to figure out what is actually this, based on its top code work. I ordered some replacement, and this was a cascading failure. The electrolytic reservoir on the secondary side failed, open a circuit. The lack of capacitance loading the transformer destroys the transistor by high voltage overshoot. Here's the transistor which is short, and this destroyed some small components around the transistor, plus the control chip. This is a power supply controller. Now let's replace or substitute all these components and C's. And of course there is still some chance these chips are fake. Just some random bits from the internet. This makes it more adventurous around this game than Resident Evil. But let's begin with the switching transistor on the primary side as a high voltage FET. It's on a sink. Heat. You have to desolder the whole heat the sink because I can't get to the screw otherwise. And that's it. The transistor is GS8 and 6. Here's the datasheet, a 6 volt and a channel MOSFET. A low figure of merit. The resistance times the gate charge. That's an interesting trick. The more powerful transistor. Let's put it on the original sink, the heat end. Let's put some paste on it. Now the new transistors on the heat sink. I should probably replace the before the transistor goes back in for easier access. Exploded 3.6 ohms. Let's just botch something together out of what I have, close enough. That's the new resistor, and this thing is for the internal resistance of resistors, but surprisingly it's also very good at measuring batteries. 220 ohms nominal, 100 ohms nominal, and in total it should be about 3. That's virtually exactly the right one. This thing also measures capacitor access. The horrible resistor botch is in now. It's going to blow up again anyway. Now the transistor goes in. Well, it could be also a better idea to replace the components around it before the transistor is in place. The 75 ohm gate charging resistor, it's not critical. I can put, for example, 60 ohms here. And the gate charging resistor is 0.2 ohms, again critical. If I put something like 10 ohms in it, it should going to blow up again anyway. Hurry, now wall bit was hurry, let's read my summers for an word. The 8.2 ohm resistor and the 68 ohm resistor goes into its place now. That's absolutely the right tool. And the other side of it, and the resistor is in play. Yeah. The 10 ohm resistor goes here, and the blown 470 ohm resistor has to go out, and donor. Now the has to go in. This might be a little bit tricky, but definitely not possible. This side, once more this side, ethanol, and a toothbrush, of course. Would you actually tell this chip was soldered using a bloody 1 volt amp soldering gun? These caps are left to figure. 1 micro 5 volts. If 1000 micro 5 volts, let's put them in. Now they're in. The original red component I could find is replaced. It's testing time. Let's first try it with a 6 watt lamp in a series. If anything goes wrong, this would limit the current. Some voltage appeared here, but it goes down. I don't know why. Maybe I have